Welcome to all of you. Today we discuss on SageMath Semester-4 Mathematics Honors, University of Calcutta, 2021 paper Special Enhancement Skill B2, SEC-B2. Now this is the question paper for 2021. First question 1A. What is the correct code in Sage to evaluate the value of pi correct up to 100 digits? Correct option is 2 in bracket pi digits equal to 100. This is the program in SageMath. Actually, this in pi comma digits equals to 100, and from this has means for remind remarks or note about this line. So this is the program in for numerical approximation. So we run this program for 100 digits, and this is the answer 100 significant figures. This you may check this for simply 5 digits. So right here 5 and run this. So here 5 significant figures 1, 2, 3, 4, 5. So here 5 significant figures. So when we put here digits equal to 5, we get 5 significant figures. Here note that we can write in place of small n numerical approx underscore approx pi, or capital N first bracket or small n first bracket or numerical underscore approx first bracket within first bracket are the same operators. And for this operator, remove this hash from this when you run this program in SageMath. These 15 significant figures, you get 15 significant figures when n pi. And if you write pi dot n digits equals to 10 for 10 significant figures, you can write this as pi dot n digits equals to 10, or round pi comma 6. For this we get 6 places of decimal for the pi. When pi dot n precision equal to 10 and precision 10 equal to 1 places of decimal, precision 20 equal to 4 places of decimal, and so on. Precision 12 equal to 2 places of decimal, and so on. So we can check it this. Question B. What will be the result of the following Sage code? Exponential 11 star 8 plus 5 minus e to the power 11 star 8 plus 5. Actual answer is 1, 0. The correct answer is option is 1. Exponential 11 start 8 plus 5 equal to e to the power this. Actually, exponential and e are the same in SageMath code. So when you run this program in SageMath, we get the output 0. Output get 0. Next question C. What will be your code in Sage to find the natural logarithm of 100 in decimal approximation? Correct option is n log 100. So this log is natural logarithm. Actually this base e and common logarithm base 10. So this option 2 is the common logarithm with base 10, comma 10. So here natural logarithm base e, the numerical approximation of this numerical approximation of log 10. So in log 100, this answer output of this answer run this program, you get this 4.605 and so on and so on. Alternatively, we can write ln 100 dot in bracket first bracket second first bracket open close, or for common logarithm you can write in log 10 comma 100 comma 10. So this 10 for the base. For natural logarithm of x is the base e, that is ln x or log x comma e are same. And for common logarithm of x, that is means base 10, so log x comma 10, log x comma 10. This is the common logarithm of this. Next question D. What will be your code in Sage if you want all the square root of 4? Correct option is 4, square root of first bracket 4 comma all equal to true. Here we get the output for this question. Correct option is 4, square root sqrt first bracket open 4 comma all equal to true. The output is 2 minus 2, 2 minus 2 third bracket. Output is this. And notice that square root 4 gives only the positive square root 2, and the first option capital SQRT, so these capital letters is not a defined function, undefined function in SageMath. So correct option is 4. Next, E, the output of Sage code, this 4 star 10 double slash 4 plus 10 percentage modulo division 4 equals 10, comma 3 star 3 less than 3. Correct option is 1, true comma false. Here there are two statements. One is this 4 star 10 double slash 4 plus 10 modulo division 4 equals 10. First statement, and second statement is this comma 3 star 3 less than 3. So 3 star 3 9 is less than 3. Obviously it is this is 9 less than 3 is false. So this statement is false. And the first statement equality sign, check the equality for the both sides. This 10 and double slash 4 means the gives the 2 is the quotient division, and division quotient after division, and this valid for the this double slash operator valid for the integer arguments. So when 10 and 4 are both integers, then this integer quotient integer divisions, this we get output quotient as quotient. And 10 percentage modulo division 4 gives the remainder division. Modulo division gives the remainder division. So when you divide 10 by 4, you get the remainder 2, and this is also valid for integer arguments. So for this we get this right hand side of this first statement is 10, and this right hand side also 10. So 10 equals 10, that is both sides are equal, so this statement is true, and this second statement is false, so true comma false. Next question F, which of the following is not the correct option for a to the power b to the power c? So power option a to the power b to the power c, actually this power sign symbol, this operator, and or double star operator, exponential operator, this, but this is this power operator, this is not valid for this. So all are correct except 3. So 3 is not correct option for a to the power b to the power c. So when you run all these we get this. If you run this, I may remove hashtag from this, so we can run for this 2 to the power 3 to the power 4 and run this, and this is the output. This is the output. This, but when you run this third third statement, 2 to the power operator this, then this, double, 3, this and this, 4 is wrong. But yeah, you can get output, but this is wrong for this calculation of a to the power b to the power c. So this is the wrong output of this. Next question G. What will be the output of the following sage code? A equal to B A4, B equal to 2, print A plus B star 2. Correct option is 8. Correct option is 8. Correct option is 8. This A equal to 4, B equal to 4, print A star B star 2. And simply you can run this. So output is 8. Output is 8. Output is 8. Next question. What will be the output of the following sage code? A third bracket 1, 3, B third bracket A 10, 20, A. Print B. So correct option is 1. Print B, so B print, so here third bracket 10, 20, and then call A, so third bracket 1, 3. So output is this. For this, output is this. Next question. What is the correct code in Sage to plot the function x cube minus x in minus 2 less than x less than 2? The correct option is 1. Plot x to the power 3 minus x comma minus 2, 2. But this option x to the power 3 is not defined in Sage code, and this range is not defined here. You can write this minus 2, 2, and this semicolon is not defined here. So correct option is 1. And when you write this Sage code, plot x to the power 3 minus x minus 2 and 2, the range of x minus 2 to 2, so you get this plot, and this the plot of this curve. J, question J, what will be the code in Sage to compute a definite integral 0 to 1 x dx by x square plus 1? And correct option is 1. Integral x by x to the power 2 plus 1 comma x comma 0 comma 1. So 0 is the lower limit, 1 is the upper limit, and x with respect to x, integration with respect to x, and this is the function. But integration is not defined here. Integral is defined function here, but here is semicolon is there, so it is wrong. And integrate is not defined function in the for calculation of integration. So correct option is 1. Here, last question 1J, correct option is 1. And this integral x by x to the power 2 this, and when you run this, you get this. If you want to the numerical value of this, so dot n, either small letter or capital N, open close interval first bracket, you can run this, and this you get the numerical approximation up to 15 significant figures in this. So this is the MCQ of this question. Question 2021. Next question 2, section 1. What are open source software? Sage is free and open source mathematical software. Explain in brief. So now what is open source software? Open source software is this open source OSS is a software that is distributed with its source code, making it available for use, modification, and distribution with its original rights. Source code is the part of software that most computer users don't ever see. It is the code computer programmers manipulate to control how a program or application behaves. Programmers who have access to source code can change a program by adding to it, changing it, or fixing parts of it that are not working properly. And open source software OSS typically includes a license that allows programmers to modify the software to best fit their needs and control how the software can be distributed. And some examples of this open source software: GNU, Linux, Mozilla Firefox, VLC Media Player, and this. and this next question, they explain the Sage is free and open source mathematical software. Obviously, SageMath is a free open source mathematical software system based on the Python programming language. It covers a wide range of mathematical areas, including algebra, calculus, number theory, geometry, graph theory, combinatorics, and much more. It is used to perform calculation, graphing, simulation, and modeling in physics, cryptography, coding theory, optimization, and indeed in all of mathematical fields. Sage, as we call SageMath for short, started with the aim of providing a free alternative to proprietary mathematical software such as Magma, Maple, Mathematica, and MATLAB, and thus it is combines the power of many existing open source packages and provides an integrated platform for open computing, education, and research. Now, the SageMath project acts as an umbrella project of open source mathematical softwares. The developer of community of the SageMath project is constantly improving Sage and related packaging, and we invite also us to help the improve the source code, please. Next question to be, write Sage code to find the difference between the golden ratio and F42 by 41 using 20 digits, where Fn is the nth term of the Fibonacci sequence. So golden ratio and the Fibonacci sequence of the 42th term and 41 first term, 41 term, 1th term, 42th term, this for this question to be, let this program P equal to a numerical approximation of golden ratio. Golden underscore ratio is the defined function in SageMath. Golden underscore ratio, comma, digits equal to 20, because here compare with the 20 digits here, 20 digits here given. So for this, the P is the variable where we store the numerical value of the golden ratio up to 20 digits. Print golden ratio, comma, P. So this print this, and definition of this Fibo M, Fibonacci series. I will define this: if 0 less than equal to m less than equal to 1, colon, return m, else for small value of n, we run this. So this is the definition of Fibonacci for Fibonacci sequences. This else return Fibonacci m minus 1 plus Fibo m minus 2. This is the definition of Fibonacci sequence. Now k is the input by the student. Enter n, input of n, and q is the numerical approximation of Fibonacci sequence k plus 1 by Fibonacci sequence kth term, and up to digits 20. Print this ratio, this Fibonacci this by Fibonacci this equal to this. So format, this second bracket is k plus 1, this second bracket is k, and this second bracket is q, is the ratio, value of the ratio up to 20 digits. So R is the absolute value of P. P is the numerical value of golden ratio up to 20 digits, and Q is the ratio of this. So here we enter the value of n is 10. So Fibonacci 11 by Fibonacci 10 equal to this. So absolute difference is this. So this is the correct program, and you can input in here 41, and so if you enter 41, value of is 41, and enter this, so this computer takes time long to compute this. So we go to the next question. Question 3. What will be the output of the following sage command? Explain your answer. Y equal to 3, y equal to 3 star y plus 1, y equal to 3 star y plus 1, semicolon y. Y equal to 3, y plus 3 star y equal to this y. Output is 31. Because first y equal to 3, this second line is this y equal to this 3 star y plus 1 is 10, and third line y equal to 31. So actual value of y is output is 31. Semicolon is this prevent the output on that line. So we put here semicolon to prevent the output on that for that line. Question 3b. What will be the output of the following sage commands? 79 by 12, 79 by 12.0, 370, 70 double slash quotient division by quotient division by 12. So here 79 by 12, here both are integer mode. So here integer division is this. So 79 by 12 is given here, and integer division is this, and b is the integer but is real mode, float mode. So here you can get this result is and float mode real value of the real mode in this real value of this, and 70 quotient division 12, and division by 12 70, we get the quotient 5, and 70 modulo division 12 give the remainder division. So we get remainder when 70 is divisible when divided by 12, we get the remainder 10. Here this. Give the output of the following sage command. Question C. 10 to the power half, comma, sine 60. There are two statements here. First is this and second is this. So for this, let a equal to this first statement, 10 to the power half, so square root of 10, print this square root of 10, and for the second statement sine 60, give the simply sine 60 here. Next question, section 2, question 4. Write sage code to plot the graphs of the following in one plot. Graph of the function fx equal to x square plus 1 in the range -2 to 2. So this is the x is the variable of x. First we define the variable of x, and fx is the function x to the power 2 plus 1, and p is the plot of f, and x comma -2 to 2, here the range -2 to 2, and df is the f dot differentiation with first order. So here the question B and question C are included here. Graph of this f dash x is twice x, and this in the range this -2 to 2 with grid lines. And question C is one big dot at 1,2 at the point 1,2 with size 40. So df we call df equal to f dot differentiation. First order differentiation is gives this df gives the first order differentiation of the function f, and this we plot g is the plot of df with color red and grid lines true. So grid lines is this up to horizontal and vertical line grid lines, and pt is the point. We define pt is the point 1,2, and this color is green color. This point is 1 at the point 1 2 is the color is green, and point side is 60. So but here each point side is 40, so we put here point size is 40 here. So color is green, and so p plus g plus pt. So p means the graph of fx, and g means graph of first derivative of fx, f dash x, and pt is the point 1 2 point, and we run this, and this is the this is the question 4 is this complete. Next question 5. Question 5a. Write sage code to plot the graph of the function given by the polar curve r equal to 1 plus 2 cos 3 theta, 0 less than equal to theta less than equal to 2 pi. is the range of this theta. So here we call t for theta, uh, variable single quote within single quote t is the theta, t for theta. And polar underscore plot, first bracket open, 1 plus 2 star cos 3 star t, comma, first bracket open, open start t, comma 0, comma 2 star pi, 2 pi, 0, comma 2 pi, and the first bracket close and first bracket close for this polar plot. So polar plot, polar function r equal to some f theta. So we can use this, and t is the parameter, sorry, t is the theta, value of theta, range from 0 to 2 pi. So we can get this polar plot of this, and this is the figure of this. Next question, question 5b, write sage code to plot the piecewise function f(x) equal to 1 plus x when x ranges from -1 less than equal to x less than equal to 0, and 1 plus x cube 0 less than x less than 1. So question 5b is we define f equal to piecewise, 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 first bracket open close, third bracket open close. You can avoid this space, this, but here to clearly mention for this, we here provide a space, this here, first bracket open close and third bracket open close. Next, first bracket open close for the first piece, and comma, first bracket open close for the second piece. For first bracket open close in the first piece, first we define the interval. Here the closed interval -1 0, so third bracket -1 0, comma, and the function is 1 plus x. Function is 1 plus x. So here we put comma 1 plus x, comma, and for the second piece of this, so here 0 comma less than 0 less than x less than 1. So this is the open interval. So here open interval 0 comma 1 comma, and the function is 1 plus x cube. So 1 plus x to the power 3 is this. And f dot plot -1 to 1 here. F dot plot means plot within the interval -1 to 1 in the x, range of x, and this function is -1 to 1, and this is the f dot, or you can write a plot of f and this. So I run this program. And this program, calling the computer of this program, so we shut down all this program. Question 5b, question 5b, question 5b, and this is the value of this. Next question 5c, write sage code to plot the function f(x) equal to 1 by x minus x in -1 to 1. Write also the equation of the asymptote if exists. So this is the function f(x) equal to 1 by x minus x, and p equal to plot a function f comma -10 to 10, y minimum is -25, and y maximum is -20, sorry, 25, and y minimum is -25, -25 here, and y maximum is plus 25 here. And detect underscore poles equal to so, single quote so. So this, by this so we can get the asymptote of this curve here, and x equals to 0 is the vertical asymptote, and the g is the plot minus x, and we here this is the y equal to minus x is the oblique asymptote of this. So color is red and line style is dot dot. So P plus G, and print the vertical asymptote x equal to 0 and oblique asymptote x equal to minus y. This is the asymptote of this within the interval minus 1 to 1, minus 1 to 1. So here you can get this minus 1 to 1. Minus 1 to 1 is this. So it is not understandable clearly for this. This is the y equal to minus x, y equal to minus is in the interval y equal to this. So we put here 10 for clearly. Minus to 10, 10 to 10 range. We type here and run this program, and so we get clearly this. Next, section 3. Write Sage code to do the following where fx equal to x cubed plus x. Find f double dash x, find f triple dash x, draw the graph of fx, draw the graph of f double dash x, draw the graph of f triple dash x, and all graphs should be in one plot. Question 6. Is this question 6? Here fx equal to x to the power 3 plus x, f2 equal to the f dot differentiation of 2 means second order differentiation, f3 equal to f dot differentiation 3 is the, for the function f third order differentiation, printf 2 printf 3. So here this the 6x is the second order derivative, x cube plus x, so 3x square plus 1 first order derivative, and 6x, so second order derivative, and third order derivative is 6. So here the second order derivative f double dash and f triple dash is 6. Now p1 is the plot of f, p2 is the plot of f2, p3 is the plot of f3, and p1 plot of f is color blue and plot of f2 is color green, and second order derivative and third order derivative is the color red. And so all graphs in one plot, p1 plus p2 plus p3, and y minimum minus 20 to y maximum 20. So we draw the graph here. This is the output of this graph. Next, question 7 is the integration. First a is the integration x to the power n, b is the integration of cos x dx by root over 1 plus sin x, c is the definite integration, d is the infinite integration, and e is the improper integration with display the 10 digits for this. Question 7. Here with this, write here variable x comma n within single quote. Assume n is less than 1 minus 1 and n is greater than 0, because if n is positive when x to the power n is positive here, here, and n is greater than 0, positive integer n, and less than 1 when n equal to minus 1, and then integration is log x. Here n equal to minus 1, x to the power minus 1, integration of x to 1 by x is the log x. So by this integration of this x to the power n plus 1 by n plus 1. So forget function, forget operator is the always remember to forget assumption as you no longer need p assumptions. So this is the assumption, assume n is condition, n is less than minus 1 and n is greater than 0. This is the condition for validity of the integration here. Or you can write this f equal to x to the power n f dot integral of x. You can write this. So we first forget this operator, and this variable of x and comma 1 in. Assume n equals to minus 1 when n equals to minus 1. So integration of 1 by x dx equal to log x. So run this program and we get log x here. And question 7b, cos x by root over 1 plus sin x. So for this indefinite integration, cos x divided by root over square root of 1 plus sin x. So f dot integral x, so we get this 2 star square root of sin x plus 1. This is the result. Or you can write integral f comma x is this indefinite integration. Or so we here put here hashtag. When you remove the hashtag for this, and here the put here hashtag to omit this line, and this run this program and the same result of this. And question C, definite integration from the limit 0 to 1 3x square and dx. 3x square dx is the C, question C. So 3x square dx integration function f integral f comma x comma 0 comma 1. This is the lower limit and this is the upper limit. So value of this integration is 1. You can easily check it. And question D. Question D is this infinite integration 0 to infinity 1 by root 2 root pi e to the power minus x squared dx. So here variable is x. F is the function 2 by square root of pi star exponential minus x square, and integral is the f with respect to x comma 0 comma infinity. You write infinity or small letter 0 0 double 0 double sorry o sorry o sorry double o. So this is the output of this. Run this, and if you put here in place of infinity, you can put double o in small letter notation. This the value is 1 same. For minus infinity, minus small o double o. And last question, E 7e, integration 0 to infinity sin x by x dx. So this is the improper integral because here 0 is undefined 1 by 0. So improper integration here variable is x and f is the function sin x by x, and integral f comma with respect to x comma 0 comma infinity, and print this is the numerical value of a up to d is equal to 10. So you can get this. If you omit this print and if you run this program in Sage, question 7, question 7e, question 7e, put here hashtag, and we want to find the value of we get here the numerical value of this up to 10 digits. And another example here, this. So SHOW show underscore this result. Computer hangs. Next, section 4, question 8. Without using inbuilt functions, write a program in Sage to determine the total number of primes less than x, print the list of such primes, and get an output for x equal to 98. Question number 8. Here X is the input, integer input, and here count is 0. This print the primes are these dot 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 for a in range 2 comma x plus 1, k equal to 0 for I in range a comma a double slash 2 plus 1 colon and indent if a modulo division I equals 0 colon k equal to k plus 1, if k is less than equal to 0 count equal to count plus 1, print a. Print the total number of prime less than this is this, and dot format x is this and this count. So here with using inbuilt function write a program in Sage to determine the total number of primes less than this. Inbuilt function without using inbuilt function. So without using inbuilt functions, output for x equal to 98, list of the primes, list the number of primes. Now number of primes, list the list of such primes and get an output for x equal to this. Determine the total number of primes less than x. Print the list such primes and get the output of 98. So if we run this program, 98 less than prime 98 less than 98 less than this, enter, and this is the list of primes. Here total number of primes less than 90 is 25, last prime is 97. So here the count, and by this count variable we count the number of primes less than this. This is the range, first initial starting 2 and the final. So this final is plus 1, final plus 1. So this range runs from 2 to x. So here the final value x plus 1, comma 1 is omitted here because 1 is obvious, increment is obvious 1 when increment is 1. So omit this increment, comma 1, omit this in the range, and note here colon and indentation after the for loop, and it is indentation after the for loop colon, and this the colon after the indentation from this. If you put a wrong indentation for this, and you get a wrong result. Carefully note this. Next question at 8b. Without using inbuilt function, write a program in Sage to determine the factorial of 10. So we want to determine the factorial of 10 here. A number equal to integer input, enter a number. Factorial of 10, factorial equal to 1. If number is less than 0, print sorry, factorial does not exist for negative numbers when number is less than 0. Else if number equals 0, print the factorial 0 is 1. Else for I in range 1 plus number plus 1, so up to count from starting from 1 to up to number. So here last value of is number, for last value of I is number and initial value is 1. Factorial equal to factorial star I. Print the factorial of number each factorial. Enter a number and factorial of 10 is this. So if we run this up to here the value of 10. So if you run for this program, enter a number, if we put here 20, enter. So factorial of 20 is this, result is this, factorial of 20, large number is here. So this is the programming for this factorial programming. Next question 9. Question 9. Without using inbuilt function, write a program in Sage to determine the decimal approximation of arithmetic mean and geometric mean of a list of numbers and get an output for the list 20, 15, 24 and this. So you can determine the decimal approximation of the arithmetic mean and geometric mean from the list of numbers. So question 9. Here the data is given. We call this list A, capital A, equal to third bracket open, third bracket closed, 20, 15, 24, 31, 45, 17. All data here, the numbers are given in the question 20, 15, and this is this. Print data list A. So data list is this, print is this output in the output data list, and L equal to the len first bracket open close capital A. This is the length of this. This len is the this function give the output length of the data. So here 1, 2, 3, 4, 5, 6. So there are 6 data. So output number of data is 6. The print number of data. So this L is 6, and sum initial sum 0, and initial multiplication 1, and here for loop I in a first I equal to, when 1 is this 20, I equal to 2, then is 15. So sum equal to sum plus I. So and multiplication equal to previous multiplication plus star I. Print sum equal to sum, print product equal to product multiplication, and arithmetic mean AM equal to sum by length of data, number of data, and print arithmetic mean equal to am dot in this numerical value of arithmetic mean, and geometric multiplication equal to multiplication to the power 1 by L, and print geometric mean equal to gm dot numerical value of this. So this program list sum is this sum plus I. So this first I equal to 1, so 20, I equal to 2, 20 plus 15, this sum, and sum increase this, and then arithmetic is total sum is this divided by number of data L, give the AM arithmetic mean, and the print this arithmetic value dot n means numerical approximation of this, arithmetic means numerical approximation of this, and geometric mean multiplication to the power 1 by L, number of data is the this. Next question 9b, with write a Sage codes without using inbuilt functions to find and print the median of the numbers 11, 23, minus 34, 40, and 50. So this is the question 9a. Question 9b. Question 9b, without using inbuilt functions find median. So A is the list of the numbers, given numbers, this print data list A, this is the data list A, L equal to length of A, alien A, this number of data is 5, print the number of data equal to L, B equal to sorted A, sorted a function, this A, sorted A means the increasing order from lower to higher, smaller to higher order. So sorted is a function increasing order. So B is the print the data in ascending order B. So this is the ascending order. The sorted is inbuilt function in SageMath. If L modulo division 2 equals to 0, colon, median 1 equal to B L modulo division 2, median 2, B L double slash quotient division double slash 2 minus 1, and median 1 plus median 2 by 2 is the actual median. So else median equal to B L double slash 2, and the pre-median is median. So data ascending order is this. So here number of data is 5. So number of data is 5 means L modulo division 2 equal to 0 means L is the even number, and here L is odd number. So L is the number root of 5. 5 modulo division 2. Here L is 5. So here L is odd number. So here L 5 modulo quotient division 2. Here 2 to 4 1 2. So this is the L double slash 2 is 2. L double slash 2 is 2. So B2 is the list is this B 1, 2, 0, 1, 2, 3, 4. So 0 counting from 0, 0, 1, 2, 3, 4. So this median is this 23. This 23. It is 0, and this list B0 is this, B1 is 11, B2 is this, B3 is this, and this L 5 by 2. So this is 2 to 4. So this 2 L double slash 2 quotient division is 2. B2 means B0 minus 34, B1 is 11, and B2 is 23. Answer is 23 because here L is odd. If L is even, then median 1 is this, median 2 is this, L double slash 2 is data, L double slash 2 minus 1 is data, and average of this median 1 plus median 2 of this. Question 10. Define a matrix in Sage whose rows are this, and give Sage code to find the row-reduced equivalent form of the matrix. So question 10a. Here, matrix A is matrix QQ, rational field, rational number of field of rational numbers, and this first bracket, comma, QQ, comma, third bracket open again, and these the rows in third bracket, first row, comma, second row, comma, third row, comma, fourth row is within the third bracket, and print a equal to this so a, and so a is the function, inbuilt function in SageMath. So we get the matrix this in row wise, within third bracket in row wise, and b equals to a dot rref, row reduced equivalent form, in short rref. RREF is an inbuilt function in SageMath. So A dot RREF, the reduced equivalent form of the matrix A. So A, capital A dot RREF in small letter, first bracket open close. This, so this is the row reduced equivalent form of A. Is this the row reduced equivalent form of A? And so B. So we get the row reduced equivalent form of A. Question 10b. Write code in Sage to find determinant A and A inverse where A is given by this. Here A matrix is given by this 3 by 3 matrix, order 3 square matrix, QQ, and third bracket open, first row, second row, third row. So this is the matrix A, row matrix A, and small a is equal to determinant A. So small a is the value of determinant A, obviously non-zero. So we can get this inverse of the matrix and print the determinant value of A, and B equal to A dot inverse. This inverse is inbuilt function in Sage. So A dot inverse gives the value inverse matrix of A. If non-singular matrix, square matrix is this. So B, we get the inverse of the matrix. A is this. So B. Next question C. Assuming the non-trivial solution exists with Sage commands to solve the following system of equations with matrix this. This system of matrix is a system of equation is this linear system of equation 3x equal to this. We want to solve this system. Here MS variable matrix space QQ 3 by 4. So this is the 3 by 4 because the augmented matrix 3 minus 4 5 14 1 1 minus 8 minus 5 2 1 1 7. So this augmented matrix is this. So 3 by 4 order, augmented matrix order 3 by 4 QQ. MS is the augmented matrix, and AB is the MS of this 3 minus 4 5 14 minus 4 5 14 row of the augmented matrix, second row of the augmented matrix, and third row of the augmented matrix is AB is the augmented matrix of this, and capital E is the AB dot equivalent form. Equivalent underscore form is inbuilt function in SageMath. So AB matrix AB equivalent form of AB matrix we put here. We store this echelon form of AB matrix in the variable E. So E, so this is the this is the echelon form of the augmented matrix. This is the echelon form, and X equals to E dot column 3. Column 3 means column 3 X equals X means X vector means small x small y small z column vector, and column 3 of this E matrix, capital E means echelon matrix. So column 3 means this column 3 3 0 1 column 3. So 3 0 1. So column 3 of this X is the solution of this solution of this x small y small z equal to 3 0 y and z is 1. So this is the solution of the system of linear equation. Alternative method, you can solve this by this alternative method. M is the matrix space. It has to define only the coefficient matrix 3 by 3 order matrix. A is the MS, this 3 by 3 order matrix, and V is the vector space QQ3. So QQ3 means this column vector 1 by 3 by 1 3 by 1 3 by 1, this is the column vector 3 by 1. So B small b equal to V of this is the vector, V is the vector space 3 by 1 vector space. So B is a vector minus 14 minus 5 7 of the capital V. And capital A is the 3 by 3 matrix of the matrix space MS. So A equal to MS of this matrix. Small b is a vector of a matrix of the V vector V vector. So X equal to A inverse B. This is A to the power minus 1, the A inverse B. So X equals to X, give the X 3 0 1, small x equal to 3, small y equal to 0, small z equal to 1. So you can solve the system of linear equation either this technique or this technique. This. Next question 11a. Write a sage code to solve differential equation dy dx equal to cos x. Question 11. Question 11a. X is the variable x, y is the function of y single quote of x, y is a function of y x, and d is the differentiation y x minus cos x, because this differentiation y x means dy dx minus cos x. This minus cos x, if we cos x in the left hand side of this equation minus cos x, so this equals to 0. So dy dx minus cos x equals to 0. So dE is the dy dx minus cos x. So dE equals to 0. So dsolve is the function in SageMath. In dsolve, this is dy dx minus cos x equals to 0. Solve for y, and y equal to sin x plus arbitrary constant c. This is the solution of this. Write Sage comment question B to solve the following initial value problem and plot the solution of this. Dy dx 1 minus y 10 equal to 2. So for when x equal to 10, y equal to 2 is the initial value problem. So x is variable x, y is a function y x, d is the differentiation of y by y comma x minus 1 plus y. Here dy dx minus 1 plus y equal to 0. So this is the d differential equation. This is the dsolve of this d equal to 0, comma y, solve for y, comma ICS initial conditions. ICS 10, 2. 10 for value of x and 2 for value of y. This 10, y10 equal to 2 within third bracket. So dsolve d equals to 0, comma y, comma ICS third bracket 10, 2. Points S, plot S, point S, this plot of a point, print S means the solution of this. So particular solution of this, this y equal to this, and for this particular solution we plot this S is particular value of this. This is the particular value of this. Next question C. 11C, write Sage command to solve the following differential equation with boundary condition x00, y x0 equal to 1, x1 equal to pi by 2, y x1 equal to 4. We Sage command to solve the following differential equation. Differential equation is this: d2y dx square plus y equal to 0. So question C, this d2y dx square plus y equal to 0. Here x is the variable x, single quote x, y is the function, single quote y, first bracket within first bracket within first bracket x. D is the differential y comma x comma 2, because here d2y dx square, second order differential. So d comma first bracket start y comma x comma 2 gives the d2y dx square plus y. So plus y. D is the left hand side of this, equals to 0. So S is the solution. It is the dissolve first bracket dE equals to 0 comma y, solve for y. Initial condition 0 1 pi by 2 comma 4, because here notice that uh, here x0 0, x0 0, y0 1. So y0 1. So here y0 1, value of x is 0, value of 1 at the point x0 is 1. This. And for the boundary condition, x1 is pi by 2 and value of y is 4. So pi by 2 is the value of x and value of x2, x1 is the x0 is the value of x0, value of y0, value of x1, value of y1, 4. This is the initial product within the third bracket. This, and print s, value of y. So y equal to cos x plus 4 star sin x. This is the solution of the particular integral, and the plot of the particular integral s is given by this. This plot of this solution is this. Next question, section 6, question 12. 12a, write a program in Sage to find the GCD of two numbers AB using Euclidean algorithm. So Euclidean algorithm is this. First we define definition GCD Mn. If m is less than n colon, print this. If m is less than, interchange the value of mn. So m comma n equal to n comma n. Here that is m equal to n if m is less than n. Print m equal to n, n equal to n. Print remainder m modulo division n, this. While m modulo division n not equal to 0, factorial sign equal to 0, that is not equal to 0, m comma n equal to n comma m modulation n. That means value of m equal to n, value of n equal to m modulo division n. That means n is the remainder of the division when m is divided by n. And print m equal to n and n equal to n. And print remainder m modulo division n is the m modulo division n. Return n. The output is n. The function of this GCD of m n, output is return is n. So a is the first number input, integer input, and b is the second integer input, second number, and we call the function GCD mn. So print GCD of this format a comma b comma GCD. First GCD of first second bracket is the value of a, and second bracket value of b format, and e is equal to the third second bracket is the GCD of ab. So when we type here GCD of ab, call the function, call this definition of GCD, call this function this. So here output is this: enter the first number 18, enter the second number n equal to 60. If m is less, interchange the values, m is less than n. Here 18 is less than 60, so interchange the value of mn. So then m equal to 60, n equal to 18, and remainder after division by n is the 6. So here m is 18 and n is 6, and again remainder here m modulo division n is 0. So when m modulo division n is 0, remainder 0. So GCD is this 6. This is the technique of this. So we can run this first number We put here first number is say 18 and second number is 30. So here the GCD of 18 and 30 is equal to 6. Question B, but 12B, write a Sage code for the following. Find the number of digits 2021 factorial and compute the number of zeros and number of ones present in 2021 factorial. And this question B is the this n equal to 2021 and this and m equal to factorial of n. F equal to m dot digits. Digits is the inbuilt function. So here number of digits in 2021 factorial is 5805. Total number of digits is this. So F gives the number of digits and L is the length of F. Alien F. Length of F. L is the length of F. Here length of F is this. And print the number of digits, this format in L. Print the number of digits, and number of digits in 2021 is L. L is the total number of digits, L. Number of digits, L. And S equals to F dot count 0. This count 0 gives the number of 0 digits in this. Number of 0 digits is 1057 in the factorial of this. And P equal to F dot count 1. So value count 1. So number of count 1 is this. So if we write here so small value of this, say n equal to 20. For example, n equal to, we run this and print the factorial in m. Here, for example, shorter example, for factorial 20 is equal to this. So here digits are 0, 0, 0, 0, 6, 6, 7, 1, 1, 8, 0, 0, 0, 0 is this. So number of digits in 20 factorial and number of digits is 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Number of digits in this factorial 20 is 19 and number of zeros is 7. 1, 2, 3, 4, 5, 6, 7. And number of 1 is only 1, is this only 1. So here the detailed structure of this. Here the new function is digits, number of digits, and then the number of digits and alien length of this F. Length of this number of digits is 19. This is the L number of digits, and L is the length. Format L in number of digits. Number of digits is L is this 19. L is this 19. Number of digits 19 digits, and the digits and list of the digits present in the factorial of 20 is this, and number of count the zeros. Number of zeros in the factorial 20 is the 7. Number of ones in the factorial 20 is only 1 here. Next question, C. 12C. Write your code in Sage to find the root of the polynomial of this fx between -1 to 1. So C is the find the root of this variable x, single quote within single quote. Fx is the polynomial x to the power 5, x to the power 4, x cube minus x square plus x minus 1. And A is f dot find underscore root -1, 1. This is the inbuilt function find underscore root. Inbuilt function in Sage within the limit first bracket -1 to 1. This print the root equal to A. So plot f comma x comma -2 2. So by this root is this 0.71. 0.71 is the root within the -1 to 1. So plot this function, plot the f function f, plot this, and root is the where the graph cuts the x-axis at this point. So this point is the 0.71, value of x is this 0.710434, and so on, dot, dot, dot. So plot this within between -2 to 2. Plot of the function is this. From this figure, we can easily detect the root of this function is this 0.71. And last question 13. Write a program in Sage to find the greatest of three given integers. Greatest of three integers. First, number 1 is this. Input this integer float number float. First number float. Second number 2 float type. Number 3 float type. Input this. If number 1 greater than equal to number 2 and number 1 greater than number 3, largest is number 1. Else if number 2 greater than equal to number 1 and number 2 greater than equal to number 3, colon, largest equal to number 2. Else, colon, largest equal to number 3. And print the largest number, which is largest number. So here we put here first number is 401, second number is this, and third number, and run this. First number is 4, the second number is -6, and third number is 9. So largest number is 9 here. 13b, write a program in Sage to find the sum of the following series for any finite n: 2.3 plus 4.5, 6.7, and so on, 2n plus 1. To find the sum of the series, this first n is the integer input, number of n terms, this n up to 10 terms or 20 terms, this. And initial sum is 0. So for I, variable I, in range 1, n plus 1. So value of I starting from 1. So value of I, first initial value is 1, and final value is n, not n plus 1, because I is less than n plus 1. And here, comma 1, increment, you can put here comma 1. This one means the increment of I. But when increment is 1, we avoid this 1. So when avoid this 1, this is the increment 1. And term, this is the term of this 2n into n plus 1. So 2n and 2i star 2 star I plus 1. This is the nth term. This is the ith term of this. Print u as terms. When I equal to 1, so first term is 6. When I equal to 2, second term is this. I equal to 3, third term is this, and this is this. So, and this s equals to s plus u. S is old sum, or first sum, initial sum 0, and then first term is 6. So 0 plus 6, new sum. And next loop, when I equal to 2, the previous sum plus new term equal to s. So print the sum of this term equal to this. So this second bracket for the n, sum of the n terms equals to second bracket. This second bracket means the sum of s of this. So you can run this for this. Number of terms is, so suppose this is 6. So first term is 6, second term is 20, 42, and this 406. And the last question of this, question C, consider the following program: I equal to 0 while I less than 5, colon, print I equal to I plus 1, if I equals to j, I equals to 3, break, else print 0. What will be the output of the following of the segment? Here I equal to 0 while I less than 5, colon, print I equal to I plus 1, if I equals to 3, colon, break, else, colon, print 0. So run this program. I equal to initial value of I is this. I is less than 5, so initial value is I equal to 0. So I run this, print I, so I 0. Print 0 plus 1, 0 plus I equal to 0 plus 1, so I equal to 1. If I equal to 3, break, else print 0. So if I equal to 3, break, stop this, otherwise print 0. So here I equal to 0 plus 1 1, so print 0, print 0. And the next loop, I equal to print I this. Next loop I equal to 1 plus 1 2. So print I is 1. So when I is less than 5, print I is this, print I is this. First I equal to 0, print I, enter the loop, print I equal to 0, print I equal to I plus 1, I equal to 1. If I equal to 3, so if not also print 0, here. Next I equal to 1, entered in the loop this, print I equal to 1, print I equal to 1. And then I equal to 1 plus 1 2, I equal to 3, no, I equal to 3, so print 0, this print 0, else print 0. And next enter the loop, I equal to uh, 2, I equal to 2, print I, so 2 here, print 2, I equal to I plus 1, I equal to I plus 1, 2 plus 1, that is 3, so I equal to 3, break in the program. And this is this. Thank you for watching this video.